Hello, my wonderful CPM students. My name is Mr. Nguyen. Thank you for joining me on this tutorial. Today we're going to do a review of different kinds of sets of numbers and reviewing the order of operations that these numbers have. Okay, so before we begin, I'd like to just take a look at the different kinds of number sets that we have. So I'm going to begin with the what we call the counting numbers or natural numbers. Natural numbers are just those counting numbers, those all of those positive numbers that you count, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They keep going. Now, notice natural numbers does not include zero, right? And then we'll talk about the next set of numbers are the whole numbers. The whole numbers will include the zeros. So we have 0, 1, 2, 3, 4, 5, and so on. So natural numbers are whole numbers, except it doesn't have zeros, okay? And then, here we go. The natural number, we use the big letter N to as a notation. Whole number is actually, we use the letter W to indicate whole number. The only difference between them is really just a zero, right? So that's why some people don't even use a symbol for that, but it's actually W for whole numbers, okay? Integers, we use the letter Z, and that includes all the positive and negative and zero counting numbers, okay? So that's kind of like the whole numbers and the negative versions, okay? And then we have rational numbers. Rational numbers are all of these and all the ones that can be written as a fraction. And we use the capital Q, the letter Q, to indicate rational numbers, right? And then there is one where they call these real algebraic numbers, or actually they are considered irrational numbers, right? So irrational numbers are numbers that are they cannot be written as a fraction, right? And they are like square roots that go on forever, but they don't follow a particular pattern. So a lot of the odd square root numbers are irrational number, like square root of 7, square root of 11, right? A lot of the prime numbers, when you square root them, they give you, you know, irrational results. So, and then outside of that, that means all of these numbers are considered real numbers, right? And then later on in the course, we'll talk about complex numbers and that kind of stuff too. But for now, for just the purpose of this practice, we're going to focus on these real number sets, okay? So that's been that. And then I'll do a few of those examples, and then I'll jump over to order of operation. Here is a reference. I'm not going to go through each one of them, but we use PEMDAS to to remind us what the orders are. We do parentheses inside first, and then the exponents on the outside, and then we're going to multiply and divide depending on what comes first, and then written from left to right, and then addition and subtraction in the same manner. Okay, so let's begin. So here's the first problem, and of course, once I start repeating, I'm gonna jump level, okay, down here. So let's begin with this one. I don't know if I need web paint, but I'm gonna open it up anyway, just in case I have to type. All right, which of the following are whole numbers? So whole numbers, remember, whole numbers are all of the counting numbers, including zero. So these are whole numbers right here. So let's go back over here and see which one that is. 6 is, 1 over 7 is not, 0 is, and now -5, if that was a +5, that would have been a whole number. But because it is negative, we don't count it, right? So just these two right here. Okay. Very cool. Which one's an integer? Remember, integers are all the whole numbers plus the negative versions, okay? So, oops, wrong one. Integers here, 1 is an integer, and the rest of them are not, okay? So this one only has one answer. Is 8 over 3 a natural number? The answer is no, because natural number are the ones you could count. You just count 1, 2, 3, 4, 5. They're whole numbers you can count, right? Whole counting numbers. So this one is not. Oh, I need to move that over there. So no, it is not. All right, next one. Is this a whole number? Of course not, because it's got all of these decimals right there, right? Okay, very cool. We're moving along here. Which one is a natural number? Remember, natural numbers are the ones that you actually count, like your fingers and toes. You know, 1 finger, 2 fingers, 3 fingers, that kind of thing, right? So 5 is, 4 is, and the rest are not. Okay, submit. Is 39 a whole number? Yes, it is, because look at this. If it is a natural number, it is also a whole number. Okay. All right. I'm going to jump level. Okay, here we go. Which of these describe? So the bar on top of the number is indicating that the number repeats, right? So this right here, I mean, it repeats. What that means, this number could be written as A4, A4, I mean, not 4A, A4, 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 and then keep going, right? 4, and then it keep going. Oops, I messed up there. A4, and then it just keep going, A4, A4, A4. So we can predict what's coming. So if we can predict what's coming, then it's considered a rational number, right? Now, if it's rational, it cannot be irrational, right? So those two are opposite. Is it a whole number? No, because it's got all these decimals. Is it a natural number? Of course not, because it's not a whole number. So rational numbers are only choice. Very cool. Next one, which of the following describes? 71 is a whole number, right? We know it's a whole number. It is also natural. It is also integer. It is also a rational number, okay? Because if you take a look over here, whole number, natural number belong to all of these, right? So if you are natural, you are an integer. You are a rational number, okay? So we're going to select all of these choices here. Okay, very cool. So square root of 28, if you have a calculator and you pop it up real quick and you type in square root of 28, you're going to see that it go on, right? It's a complicated decimal value. It doesn't, we don't know what's about to come up because it doesn't have a particular pattern. So we're going to say that, oh, this is an irrational number. But what if you don't have a calculator? Well, if you don't have a calculator, you know that 20 square root of 25 is a nice whole number. And then the next nice whole number would be 36. So anything in between these, square root of 24, square root of 30, square root of all of those, look at this, let me try square root of 35 and let you see. All of those are going to be irrational, okay? So I'm going to say it's irrational. Submit. 66 is a natural number. If it is a natural number, then these will apply as well, okay? It is also an integer. It is also a whole number, okay? 56, it is a whole number. It is a natural number. It is also an integer. That was a repeat. Submit. All right, I think we're going to stop here. If you want to go all the way to 100, you're more than welcome to, but I'm going to, for the sake of time, I'm going to jump to the next practice we're doing, which is order of operations, and this one might take a little bit of time, right? So if you're doing this on your own, you can go ahead and get all the way to 100. Okay. All right, here's order of operations, and I think I will need this wet paint. So remember, order of operations, we got, if you look over here, you have division and addition. Division needs to come first. So we have to divide, then add, right? But in order to divide fraction, we are multiplying the reciprocal of reciprocal. Okay, that's it. So in this problem, I will be doing this, and then excuse my handwriting. I'm going to be doing 1 over 5 and it's going to be times. This right here needs to be reciprocal. Reciprocal of this just means it's the flip. So it's going to be 4/1. Okay. And then whatever the answer is, we do this first, and then we add 3/5 to that. Yeah, 3/5. Okay. So now I'm doing this without a calculator because if you're taking CP/M and you're going to take the TSI test later, they're not going to allow you to use calculator. So we're going to do all of this math without calculator, okay? And yes, I understand it might take a little bit of time, but we need to know we need this skill, okay? So when you multiply in fraction, you just multiply straight across. So it'll be 1 times 4 is 4, and then over 5 times 1, which is 5. And then I'm going to be adding 3/5 to that, so 3/5, okay? And if you're adding fractions that have the same denominator, you just keep the same denominator, 5, right? And then you're adding the denominators. The denominator is the same. You are going to add the numerators together. You get 7, okay? So the answer to this problem is 7/5. So I'm going to type it in a fraction, 7/5, and we're going to submit that. Okay. For this one, we have multiplication here, and then looks like it's addition here, right? So what I'm going to do is I'm going to, if you want to, so I'm going to draw the parentheses to let you see. We're going to do this first. Okay. So we take 3/5 and we let it sit by itself for now. Okay. We're going to do the multiplication part first. So this is going to be -1 times 1 is -1 over 2 times 5. So 2 times 5 is 10. Now, why don't I use that negative again? Well, because it's already been used. -1 times 1, okay? And then now I can do the subtraction. But before I do the subtraction, I need to make sure this is a 10. I need this to be a 10 because it has to be the same as this one, okay? So how do I make this a 10? Well, I can multiply this by 2, and I can multiply this by 2, okay? So I have 6/10 minus 1/10, okay? And so you keep the same denominator, which is 10, and then you subtract the numerator. Okay? So the denominator is 10, and then 6 minus 1 is 5. Next. Wonderful. Okay. So yes, doing this by hand with fractions will take a little bit of time, but multiplication is not as bad. Okay. Writing this on the computer, it's taking a long time. So anyway, maybe I can type. Okay, I'm going to try typing. Maybe typing will be a little bit faster. All right, first we have to do multiplication first. We're going to multiply this first. Okay, so we're going to keep 1/2 alone, 1/2. Okay, we're going to leave it there. I don't like typing fraction like that, especially if we're doing this numerator and denominator business. I want to keep it like that, okay? And then we do this. 3 times 3 is 9, so we're adding, right? We're keeping the sign right here, adding, right? 3 times 3 is 9. And then all of that is over 5 times 4, which is 20, okay? And now, notice that we're adding. If you're adding, you have to have the same denominator. So this needs to be the same as this. Okay, so I need to have 20 on the bottom. So on top, the 9 is okay. The 9 already has the 20 on the bottom, but this doesn't. So in order to get 20, I have to multiply this by 10. That means I have to multiply this by 10 to get even, right? So the top here, 1 times 10 is 10. And so 10 plus 9 is 19. So the answer is 19/20. 19/20. Okay. The order of operations. Okay. All right, let's try this one. Oh, this one has multiple ones. So what do I do first? So this one, division and then multiplication. I have to divide first. and then I multiply, and then I multiply again. Well, if you multiply by anything by a 1, it's the same. So you could probably forget this one right here. You don't even need this, okay? Because 2 times 1 is 2, right? So you don't even need to multiply by a 1, right? So you can just forget it. All right, so let's find out what this is. So if I do dividing, I need to multiply the reciprocal. So you could actually do this. 1 times 2 is 2. And then 4 times 1 is 4. And then times 2 over 5. Okay. Well, 2 times 2 is 4. 4 times 5 is 20. Now, 4 over 20 is 1 over 5, because 4 go into 25 times. Now, if you don't want this big answer, you could actually reduce this ahead of time. This is 1 over 2, okay? And then you say 1 times 2 is, oh, this is, okay, and then, so that's 2, and then 2 times, and then that reduces it, but then you can also cancel the 2 and the 2. So now your answer is 1 over 5, right here. Okay, so you could actually do that cancellation. Only works when you're multiplying, okay? So it'll be 1 over 5. That's our answer. All right, this one, same thing. We're gonna do, oh, wait, is that a new problem? It looks different. We do this one first. Oh, it's different because it's right here. And then we do this one, and then we add, right? So here's the order. We have to first divide the fraction, okay? Multiply fraction, and then add the results. Okay, finally. Okay, so I'm gonna do that. I'm gonna do this. 4 times 2 is 8 over 5 times 1 is 5. I'm doing that because it's dividing, right? Here, I don't do that. I just do 1 times 3. So I'm adding right here. 1 times 3 is 3. And then 5 times 4 is 20. Now, I'm adding, that means I cannot cancel anything, right? Not across, at least. But I do need to make this 20. So I need to make the whole bottom 20. Okay? Now, the 3 is fine. The 3 is okay, because it's already 3 over 20. The 8 is not. The 8, I need to multiply this by 4, because 5 times 4 is 20, and I need to multiply this by 4. 8 times 4 is 32. So my final answer is 35 divided by 20, right? 35 divided by 20. So what if I type that in? 35 divided by 20. Here's the question. Can I simplify this? Okay, so can I simplify 35 over 20? Is there some number that can go into both 35 and 20 evenly? Well, the answer is yes, sir. You can divide both of them by 5. You can divide this one by 5. Okay. So this will become 7. 35 divided by 5 is 7. And this will become 4. Okay. Now, if you happen to type in 35 over 20, the answer is going to be wrong, because they want you to write this as a simplified answer, right? So I'm going to type in 7 over 4 instead. 7 over 4. All right, so this one, so we have add, divide. We have to do the division first, okay? And then we can add these together, okay? So that is gonna, because they're separate, we can add that together. Actually, yes. And then we can add the result of this to this. Because this is dividing, I'm going to do like that. So -1 times 3 is -3 over 2 times -2 is -4. We have two negative, which means we're going to get a positive number because negative divided by negative is positive. So +3/4. Okay. So now we can do this together, that right there. This is going to give us +2/5. And so we're going to add the results right here, which is 3/4, right? We're going to add 3/4 over here. Now, here's the problem with this. I hope you guys remember. These needs to have a common denominator. So what is the common denominator? What is the largest number that both 5 and 4 can go in? Give you a minute to think. 20. 5 going to 20 4 times. So I have to multiply this by 4. 4 go into 20 5 times. 4 go into 20 5 times. So I have to multiply this by 5. Okay. So now I got to simplify this. 2 times 4 is 8 plus 3 times 5 is 15. Okay. So now I can add them. 8 plus 15 is 23. So my answer here is 23/20. 23/20. So hopefully I didn't mess up my math. Let's submit. All right, mixed number. Let's do some mixed number problems. Let's do this one. So we got to change this to a fraction. And then I'm going to change this to a fraction. And I'm also going to take care of these two right here. The negative and the negative actually turn into a plus, right? Okay, so what is -5 3/5? Okay, what we do is we multiply and then we add. Okay, multiply and then we add. So this is negative and then the 5 is down there. So 5 times 5 is 25. 25 plus 3 is 28. Okay, and then here it's plus, right? So this one is 1 1/4. Positive, okay, equals. Or 1 times 4, the fraction needs to be there, the denominator. 1 times 4 is 4. 4 plus 1 is 5, so it's 5/4. Okay, so I put those numbers in there. I got 6 plus or minus 28/5. And then plus 5/4. And then divide by 5. Okay, so what do I do first? Well, remember division comes before adding or subtracting, so I have to do this first, right? And this 5, it's like 5/1 because it's 5, right? And so because I am dividing, I'm actually multiplying the cross product. So 5/4, the reciprocal I meant, times 1/5. The 5 will cancel, and then you get 1/4. That's your answer for this part right here. So let's put it all together. 6 minus 28/5, and then plus 1/4. Okay, so now I need everything on the bottom to be 20. Okay, so this, to get me a 20 on the bottom, I need to multiply by 20. 6 times 20 is 120. Oh, that's a huge number. I think I'm doing this right, okay? And then here we have times 4, 28 times 4. Okay? We have to multiply this by 4 because I have to multiply the bottom by 4. So you got to multiply the top by 4. 8 times 4 is 32, and I have to do the minus sign. 8 times 4 is 32, write the 2, remember the 3. 4 times 2 is 8, plus 3 is 11. So this whole thing is 11 and 12. Okay, and then I add, it's not 1 because 4 times 5 give you 20. So the top needs to be multiplied by 5 as well. Okay, so it's going to be 5. Okay, so let's do all of this. We have to do 120 times 120, take away 112. Guys, I'm doing all of this by hand because I'm not allowed to use a calculator. So that gives me 8 left. Okay, and then I'm adding 5 to that. That's going to give me 13. And then all of this is over 20. So my final solution is 13 over 20. Okay, so if you get to this point and if you can do a problem like this, your number skills are actually pretty good because look at this problem. It's very involved, okay? And God, I'm going to be really mad at myself if I put this in and the answer is wrong. That means I've made a mistake somewhere. Whew. Fantastic. All right, you guys, I'm going to stop here. You guys can try to get to maybe an 80. I'll be happy if you guys can stop at an 80. And let me know if you have any questions. You can send it directly to my email. Other than that, go have a good day and go do your practice. Thank you so much for watching. Bye-bye.